Hello guys, welcome back to my channel. Today's our topic is Floyd's algorithm in design and analysis of algorithms with more information. Introduction to Floyd's algorithm in design and analysis of algorithm. Floyd's algorithm is a graph traversal algorithm used to find the shortest path between all pairs of vertex in weighted graph. It was proposed by Robert Floyd in 1961 and 1962, and it was also known as a Floyd-Warshall algorithm. This algorithm is based on dynamic programming techniques and has a time complexity where v is the number of vertices in the graph. Problem statement: finding the shortest path between the all pairs of vertices in a weighted graph. Given a weighted graph, the goal is to find the shortest path between the each pairs of vertices. The weighted graph heads represents the cost or distance between two vertices. The algorithm should return a matrix that shows the shortest path distances between all pairs of vertices. Approach overview. High level steps of Floyd's algorithm. Initialize a distance matrix with a weight of the edges in the graph. For each vertex and immediate vertex, update the distance matrix by considering all the possible paths. Iterate over the all vertices and update the distance matrix if a shorter path is found. Imagine imagine a graph with four vertices A, B, C, D, and the following of edge vertices A to B 3, A to C 7, B to C 1, B to D 5, and C to D 2. Your second bullet and your third bullet. The distance matrix is filled with the weights of the edges in the graph. If there is no edges between the two vertices, the weight of the vertices set is infinity. In our example, the initial distance matrix will be A to B, but A to D is infinity. Step 3. Intermediate vertex. Selecting an intermediate vertex. For each vertex, the graph we have considered it as intermediate. In our example, your third bullet. For each pair of vertices, if going through the intermediate vertex reduces the path distance. For example, we are updated the distance of matrix of vertex intermediate of vertex, illustrating our overall vertices as a intermediate vertices. Repeat step 2 and step 3 for each vertex in the graph. In our example, we will continue with the vertices BCD, BC and D with intermediate vertices, your third bullet. We update the distance matrix using the same logic as at the step 3, but considering the new intermediate vertex. In our example, we will update the distance matrix for vertex BC and D, your third bullet. Continuing the iteration, continuing the iteration for each remaining vertex in the graph. In our example, we have completed the limitations for all vertices. After completing all iteration, we obtain the final distance matrix. It represents the shortest path, the distances between all the pairs of vertices in the graph. As a time complexity where v is the number of vertices in the graph. This is because we perform the nested loops all over all vertices to update the distance matrix. Time complexity is OB to square to store the distance matrix. Floyd's algorithm is simpler to understand and implement. It guarantees finding the shortest path distances between all pairs of vertices. It works for both the directed and undirected graphs. Disadvantages. Limitations of Floyd algorithm. Floyd's algorithm has a time complexity of V cube, which can be insufficient for large graphs. It requires storing a distance matrix which consumes a significant amount of memory for large graphs. It cannot handle negative cycles as they would result in the infinite loop. Practical applications of Floyd's algorithm. Floyd's algorithm is commonly used in network routing algorithms to find the shortest path between routers. It can be applied to solve the problems involving finding the shortest path in transportation. Networks such as road networks or airline routers. Used to in computation biology to analyze the genetic sequences and find the uh, evolutionary relationship. GPS navigation used the Floyd's algorithm for GPS navigation systems use the Floyd's algorithm to find the shortest path between between locations. The white graph represents the road network and the edge white represent the distance or travel times between the algorithm helps in finding the optional route from the current location to the destination. In the social network analysis, the Floyd's algorithms can be used to measure the closeness and centrality of individuals for represents the connections between them and the edge represents them finding the shortest conclusion. Floyd's algorithm is a graph traversal used to find the shortest path between the all pairs of vertices weighted graph. It is based on the dynamic programming techniques and has a time complexity of V cube. The Floyd's algorithm find the shortest path between the all pairs of making it applicable in various domains. Thank you. References list of references is used for the representations introduction of the topic algorithms. Questions. Open the question and discussion. Your second bullet and third bullet. Thank you.